Today we are going to create an Xbar-S Control Chart together. The S for standard deviation, while Xbar represents the average of the sample measurements. For this hands-on example, we will use the SIGMADESK Control Chart Generator and learn all the fundamentals in a practical way. If you would like, you can create a free account on SIGMADESK and follow along step by step. First, from the home page, I select the Control Chart Generator, which takes me directly to this simple interface. In previous video, we covered the IMR chart and also Xbar-R chart. For this video, I will switch directly to Xbar-S chart, but I strongly recommend watching the other videos on the channel so you can clearly understand the differences. So here in this interface, the only thing I need to do is copy and paste the dataset into spreadsheet, or load one of the control charts I saved earlier. I will go with the second option and load the chart that I saved earlier. From the chart options, I simply load my saved chart. You can also save and modify your own charts anytime. Now our dataset is loaded and the Xbar and the S chart has been visualized. Before we interpret results, let's take a quick look at the theory behind Xbar and S control chart type. Let's assume a pharma company produces painkiller tablets. In every batch, an automated system measures the weight of 5 tablets. When we discussed the eye chart, every individual measurement was plotted directly to the chart. Now for each subgroup of 5 measurements, I calculate the average and plot those subgroup averages onto a new chart. This is called Xbar chart. The center line is simply the average of all subgroup averages. Then we have the upper and lower control limits, which represent the range where I would expect the measurements to fall within in a stable process. Now let's move on to S chart. Again, we divided the measurements into subgroup of 5. This time, we calculate the standard deviation within each group. The chart that plots these subgroup deviations sequentially is called the S chart. The center line on the S chart is the average of all subgroup standard deviations, and the upper and lower control limits help us understand whether the variation within the subgroups is statistically stable. Using Xbar and S chart together is extremely useful because they allow us to monitor 2 different types of variation. With the Xbar chart, we monitor the variation between subgroup averages, which reflects variation between painkiller production batches in our example. With the S chart, we monitor the variation within each subgroup using standard deviation, which reflects the consistency inside each production batch. Compared to the R chart, which we explained in the previous video, the S chart provides a more statistically sensitive estimate of variation, especially when group sizes are larger. That's why Xbar-S charts are commonly preferred when subgroup sizes are moderate or large. If it is smaller than 10, usually both are okay. We are not going into details of how the control limits are calculated for Xbar and S chart in this video. If you would like to learn more about these calculations or how sigma is estimated, especially for these charts, you can check out our detailed control charts video. Control limits are also calculated differently depending on whether the Xbar chart is paired with an S chart or R chart, even though they are still Xbar chart. This comes from the difference of sigma estimation, and this difference may vary depending on dataset and group size. We also covered these details in the control chart guide. And of course, you don't need to know all the formulas to make observations. SIGMADESK and other statistical tools automatically handle the calculations for you. Now let's review the chart in SIGMADESK. By separating these 2 sources of variation, we gain a much clearer understanding of overall process stability. Both charts are valuable when identifying statistical abnormalities in a process. Here in the Xbar chart, we can see the center line, the upper and lower control limits, and the total number of data points, and how many subgroup averages fall outside the control limits, and the estimated process standard deviation. These are the main components of an Xbar chart. You can also analyze violation patterns using the Western electric rules. There will be another video explaining the details of Western electric rules. It's a very useful and easy method for identifying abnormal patterns in a control chart data. Now let's move on to S chart. Here again, We can see our metrics on the right side and the visualized chart and the limits on the left side. And that's it. You have successfully created an Xbar-S chart. If you would like, you can also practice on your own. You can try the tool yourself on SIGMADESK. If this was helpful, don't forget to like the video and leave your questions in the comments below. I will try to help everyone. Thanks for watching. I will see you in the next video. Goodbye for now.